Good to see you, Stephen.
It's good to see you too, Sarah.
Stephen, could you explain the challenges you face in your role?
Certainly, one of the biggest challenges is demonstrating good environmental performance at our sites. You know, it's critical for a number of business reasons. We have obviously a regulated compliance to achieve, but we also want to have minimal impact on the environment. We want to demonstrate good performance to our customers, to our stakeholders, and ultimately to the people buying our product. You know, there's increased recognition now of the provenance of food, and we want it to come from responsibly run, good performing, environmentally compliant sites.
How do we do that?
We do that at the moment by seabed sampling. We take grabs of sediment up onto the deck of the boat. It's sieved and sorted, and then it goes away for analysis, faunal analysis. It's basically species identification. We have about 56 sites. Not all operational at any one time, but over the course of a year, we would probably sample 30 sites.
So this leads me on to the exciting bit I want to speak to you about, and a project that we've worked on together for a while now.
Yes, DNA-based compliance solution. SEPA have introduced a new regulatory tool for compliance, for seabed compliance, using DNA data.
And this has come, Stephen, working with academia, take funding for yourself.
The Meiometbar project had its genesis in 2016 and it got up and running in 2017. We were involved at the start, and then Scottish Sea Farms came into it as well. But we also had SEPA as a regulator involved. We had academic involvement through SAMS and University of Highlands and Islands, and we also had obviously SAKE, who were the funding partners, which was key. I mean, SAKE brought everybody together. It was a really collaborative project. It was a long project, but it was a complex subject. Lots of data had to be produced. But the outputs are promising, very promising, and potentially very important and beneficial to the industry.
So what could sampling look like now with this eDNA?
Well, at the moment we're taking a 20 kilogram sample of sediment from the biggest grab, and that's been processed. The new DNA approach will take 10 grams of sediment in a small tube. It'll go away. It'll be easier to get away to the lab. Obviously, the quantity of the volume of samples for sending away will reduce. But we should get that data back a lot quicker. And we can also use that data ourselves to inform adaptive farm management. We can almost like in real time assess the trajectory of benthic change.
Yes.
And then we can be responsive to that and apply actions as needed.
And has it got more to come, Stephen, in your view?
Yes, there's more to come. Well, at the moment, SEPA have taken the outputs from the first project, Meiometbar, and they've developed a DNA screening tool using bacterial DNA to produce the IQI scores. That tool is limited in respect of the types of seabed that it's applicable to, because of the tests, the sites that went through the process. So there's a second project, Meiometbar, which is looking to expand the range of sites that we have DNA samples from, and the whole industry is involved with that.
Wow, it seems really that there is a chunky output from this that is practical.
There would, yeah, absolutely, yeah. It's a significant output because the standards we have just now are essentially 30 years old. I mean, the building blocks of the standards are still essentially what was developed pre-1996 by the former river purification boards. So it's a significant evolution,
Yeah, and potential to go beyond, as you say, not just other sediment types, but potentially water classification.
Absolutely, yeah. DNA-based monitoring has been used in a number of nature-based assessments now for a wide range of environments, terrestrial and the water. So yeah.
Really exciting to see the farm and the science come together to give us a step forward. Really exciting to see. Thank you, Stephen.
Pleasure.